Hello guys, today we will solve a problem about the chapter 3 of fluid mechanics, the total hydrostatics force and surfaces. The problem is, a block of wood with a dimension of 0.6 meter by 0.6 meter by h meters was thrown into the water. It floats with 0.18 meter projecting above the water surface. The same block was thrown into the container of a liquid having a specific gravity of 0.90 and it floats with 0.14 cm projecting above the liquid surface. Determine the value of h and determine the specific gravity of the block and determine the weight of the block. The given values are 0.6 meter by 0.6 meter by h meters is the area, with the height of, the block that thrown into the water is equals to 0.18 meter, with the specific gravity of oil equals to 0.90, and the height of the block that was thrown into the oil is equals to 0.4 meter. So we will going to use the formula weight is equals to buoyancy force, in which buoyancy force is equals to unit weight multiplied to area multiplied to height. So unit weight multiplied to area multiplied to height is equals to unit weight multiplied to area multiplied to height. We have Sg times height times 9.81 kilonewton per cubic meter times 0.6 meter by 0.6 meter is equals to 9.81 kilonewton per cubic meter times 0.6 meter times 0.6 meter times h minus 0.18 meter. Cancel out the same units. We have Sg times height is equals to h minus 0.18 meters. With the use of same formula, we have unit weight multiplied to area multiplied to height of an oil is equals to unit weight of water multiplied to area of the water multiplied to its height. We have h times 0.6 meter times 0.6 meter times 9.81 kilonewton per cubic meter is equals to 9.81 kilonewton per cubic meter times 0.90 times 0.60 meter times 0.60 meter times h minus 0.14 meter. Cancel out the same units. We have h is equals to h minus 0.14 meter multiplied to 0.90. Plug in the two equations. We have h minus 0.18 meter is equals to 0.90 multiplied to h minus 0.14 meter. We have h minus 0.18 meter is equals to 0.90 h minus 0.126 meter. Transpose the 0.90 h into the left side. So we have h minus 0.90 h is equals to 0.18 meter minus 0.126. So we have 0.10 h is equals to 0.054 meter. Divide both sides into 0.10. We have 0.10 h over 0.10 is equals to 0.054 meter over 0.10. So we have the value of height, which is 0.54 meters. Next, we will solve for the specific gravity of the block. We use the formula specific gravity multiplied to height is equals to h minus 0.18 meter. Plug in the value of the height, which is 0.4 meters. We have Sg times 0.54 meter is equals to 0.54 meter minus 0.18 meter. Divide both sides into 0.54 meter, we have Sg times 0.54 meter over 0.4 meter equals to 0.36 meter over 0.54 meter. Cancel out the same units, so the value of our specific gravity is 0.667. And lastly, we're going to solve for the weight of the block. We were going to use the formula weight is equals to unit weight multiplied to height multiplied to its area. Plug in the values, we have 9.81 kilonewton per cubic meter times 0.667 multiplied to 0.54 meter times 0.60 meter times 0.60 meter. Cancel out the same units, we have 9.81 kilonewton times 0.667 times 0.54 times 0.60 times 0.60. We have the total weight of 1.272 kilonewton. That's all for today. I'll see you in our next video. Thanks for watching.